Alright nerds, so let's have a look at the idea of simple machines and really see if we can nail our vocabulary with this stuff. So our learning goal here is to understand the basic vocab of simple machines. And when we know we've done that, we'll be able to explain what a simple machine is using the specific vocabulary. And another thing you're going to be able to do at the end, if you've understood it all, is that you'll be able to calculate, say, the work done or the mechanical advantage of some simple machines if you're given enough information. So first off, this is a very, very good example of a simple machine. This is a ramp or an inclined plane. But what is a simple machine exactly? It's basically any device that reduces the amount of effort or force that's required to do a simple task, like move an object. In fact, moving objects is pretty much what we're going to be talking about. It's really important to realize that it does not reduce the work or energy required. We don't get something for nothing. Okay? What we've got to remember the law of conservation. And if you need a quick refresher on that one, go check out that video, and just to make sure you understand it all. Now, one thing that can happen is it might actually increase the amount of energy required, because of a force that's going to act along here, friction. And we also need to remember that a force is anything that causes a change in motion, and sitting still from sitting still to moving is a change in motion, and it's anything that's a push, twist, or pull. Simple machines reduce the effort required, but not the amount of energy. That's the quick little summary there. So a simple machine will reduce the amount of force required to do something, but not the amount of energy. So some simple machines, basically they change the size of the force, or they change the direction of the force, or they change the speed. Here we have, so previously we have a ramp. Here we have a lever or a lever. Here we have some pulleys. Pulleys are actually pretty cool. And here we have a screw or a helically inclined plane, i.e. a ramp that goes around a spiral. Yes, so let's go a bit more vocab while we're at it. What is a complex machine? A complex machine is basically something which puts together various simple machines. It's also called a compound machine. Alright, so work. Work is the effort required to move an object multiplied by the distance. So force, if you remember correctly, is in the units of newtons. Distance we measure in meters, and the unit is joules. This is a unit of energy. So work is the amount of energy it requires to do something, or the effort, so force, times by the distance you want to move something. So if we have a look at that as a question, we go work equals force times distance. By the way, if we were to write this as a straight formula, it would be work equals Fs. And S in physics or science is distance. So machines do not decrease the amount of work, but increase the distance so that the force decreases. So increase the distance. So if this number is to stay the same, right? So when we're talking about work, we're talking about amount of energy. So if we want to talk about lifting something, moving something, without using a machine, it will take a certain amount of energy, which means we've got to use a certain amount of force to move it this distance. What actually happens with a machine is we increase the distance. Okay, so distance goes up. Remember, this number is staying the same, so force goes down, which means it's easier. Less effort is required to move it over a longer distance. So this is how this calculation works. We've got here a little example. 100 newtons moves a 15 kilo object across a horizontal distance at 5 meters. So our work equals 100 times 5. So force is 100 newtons times 5 meters. Gives us 500 joules. That's work, and that's how we calculate work. It's pretty straightforward, actually. So let's have another thing. Let's have a look at the word load. So load is basically the force required to actually do the job. In this case, so if we want to just lift this box up here, the amount of energy required to lift it, or the amount of force required to lift it, is the load. The machine makes that easier by pushing here. We'll talk about how levers work in a different video. That's the effort. The effort is the amount of force it takes to do it once using the machine, but the load is the raw force that it requires. And because there's a difference between the raw force or load and the effort, this means machines give us a mechanical advantage. And a mechanical advantage is a simple number with no units at all, because it's a ratio, and it's the ratio of applied force, force produced by a machine, so that's the load, to the force applied to it. Okay, so here we're required to lift 50 newtons to lift this stuff in his wheelbarrow, dirt by the looks of it, which means it's only going to take 10 newtons to lift that up, because of the distance of the machine and the fulcrum and everything else that we'll cover in another video about levers. Again, another lever, but as it's 50 newtons divided by 10 newtons, the mechanical advantage is 5. Alright, so I hope that made a lot of sense. If you have any questions, put them in the comments below and we'll get back to you as quick as we can. Thanks for watching. See you next time. Bye now.